Now that my SWAT project is set up, the first step is to delineate the watershed. So ArcSwat is going to use the elevation raster that I have, and it's going to figure out the watershed for my reservoir, and it's going to figure out where the streams are, which is the first thing that the model needs. So if I go to Watershed Delineator, I want to do automatic watershed delineation. Now, a lot of times I get this error, and it seems to run fine, so I'm just going to hit OK. I'm not really sure what's going on there, but that happens a lot in ArcSwat. Sometimes it's a big problem, sometimes it's not a problem at all. So what you see here is how many of the windows are set up. Much of this is grayed out because you can't do any of it. So you start with the first step, and then as you accomplish steps, things become available to be clicked on. So the first thing we got to do is tell it where the DEM is. And I'm going to load this from the disk. And I look into my folder, and here is the elevation raster that I already have. So I'm going to add that. Now, I can always shrink this window to look at my map. And if I bring my polygon shapefile on top of that, you can see where Spring Lake lies. Let me zoom out, and you can see the elevation data set that I'm working with. This is a clip of a larger raster, but you can see the general stream network that's going to flow into Spring Lake, and then below the dam in Spring Lake you can see where it heads off down to the Lemoyne River, which you can see down here in the southeast corner. And you can see some of the other tributaries that are going to other watersheds. So you can tell that our watershed is going to be right here in the middle. So let me bring that window back up. And you see now I have some options that are available. The first is DEM projection setup. So we have to tell ArcSwat what units this DEM is in. And it recognizes that the XY units are meters, but it doesn't know what the elevation is. In this particular DEM, the elevations are in meters. And it calculates the cell size as 27 meters, which is roughly the 30 by 30 meter that we expect. And it also recognizes that we're in the UTM projection, which is what we want. So we hit OK. Now there are a couple other options here where you can use a mask. If you have a larger DEM, you can mask it, but I found it's easier just to cut down your DEM or your NED to the size you want. Burn in, I forget what that is, but we don't need it. So the next step is to define the streams within the watershed. And we could use predefined streams if we already knew them, but we don't know them. So we're going to have the software use this elevation model to determine where the streams should be. And so the first step is to get flow direction and accumulation. So let's hit this button. And it's determined the direction and accumulation, so we hit OK. And now it's determined roughly what the area is and the number of cells. We can adjust this, but the default usually seems to work just fine. We don't have any predefined streams, so these are grayed out. Now you see that we can determine the stream network. Here it determines which direction the flow is going to go and where the flow is going to accumulate. And so once you know that, now you can draw streams. So let's have it draw the streams. And look at that. Now let me shrink that window again, and you see that it figured out exactly where all the streams go in this DEM. And you'll also notice, if we zoom in, that it's put points near the confluence of all these streams. So every time two streams come together, oh, that's a bad one, that's too dark, let me find a lighter one. Every time streams come together, it automatically puts a control point at the end of each stream. And this is what it's going to use to determine the watershed for that stream. So basically, the watershed for this stream is the whole area that drains through that point. And the watershed for this stream, or the sub-basin for this stream, is all the water that goes through that point. So it's really nice. It's really smart. Now if we zoom in on our reservoir, we see we've got a stream coming in here and here. So we've got a couple of sub-basins. And then you've got a couple of more sub-basins that flow in to Spring Lake down here. So basically this point right here is where the whole watershed for Spring Lake ultimately goes through this point. And of course you can see that that is at the far west end of the lake, just like we would expect. Now if we go back to our window, we see that now we have the option to define sub-basin outlets, which the major ones have already been defined, but we can add more if we want, if we have particular places that we want to measure, that we want to calculate the watershed for a particular place. Well, we want to calculate the watershed for Spring Lake, that spot that I just showed you. So I'm going to go ahead and hit add. And it says left click everywhere I want to add a point, right click to stop editing, which is great. So now I'm going to zoom back down to Spring Lake. And I am going to say that this point is going to be define the entire watershed for Spring Lake. Everything that falls above this point is going to ultimately end up right here, every drop of water, and that is what's going to end up in Spring Lake. That's the only one I want to define. So I'm going to right click, stop editing, save my edits, and if I go back to my screen, I can go and add more if I want. So for example, let me shrink that again. Let's say that I was interested in the watershed above this point. I could put a point there too, and it would define a sub-basin that drains through that point. So anywhere on the stream network, I can put a point and the model will define a sub-basin above that point. But right now I'm only interested in what goes into Spring Lake, and so I only define that one point. I can also connect different watersheds, and so I can show that there's an inlet where another watershed drains into this one. If I have a point source where, for example, sewage runoff or something, I can define that. If I have a lot of them and I have a table of them, I can data that. We're not going to do any of that right now. Okay, and of course I can delete points and redefine if I feel like I need to, but I like the points it's given me. So now I'm going to hit this button to define the whole watershed outlet. That's why I defined that point that I just did. So I'm going to click on this. It says hold down the left mouse button and drag a box to select outlets. So I'm going to zoom back into that point I just created. Oops, that's the one I was just showing you. I'm going to zoom into this point. And I need to go back to get back to my tool here. And when I select that point, I've got one outlet selected. I've just told it that the whole watershed empties through that point. That's what I want the model to determine. All these other points are sub-watersheds or sub-basins. So that's a sub-basin, a sub-basin, a sub-basin, a sub-basin. But this one point that I just selected, the whole watershed is going to go through there. So now it knows that. Now I can delineate the watershed. So now it's going to define sub-basins for every one of those points, and every one of those sub-basins is ultimately going to drain through that one point that I just selected. So the whole watershed is made up of sub-basins. So that didn't take long. Let's hit OK. Let's shrink this. Let's zoom out. And you see that it has defined the Spring Lake watershed. This pink area, any drop of rain that falls in there ultimately has the potential, if it doesn't evaporate or get used by a plant, it's going to end up in Spring Lake. And then if I zoom in on any one of these subbasins, you see that above each of these subbasins, I've got a each of one of these subpoints, I've got a subbasin defined for each one. Pretty slick. So the last option here is to calculate subbasin parameters. So now ArcSwat needs to know the size of each subbasin, how much slope it's got, things like that. I'm not sure exactly everything it defines, but it needs to calculate all these parameters. We don't really want to check any of these boxes. Let's just let it work. You see that I've got 25 outlets, 25 subbasins. So it's calculating parameters for every one. And there we go. So we can hit OK. And if you want, you can show it where there's a reservoir, because it can model a reservoir. So if you had a reservoir or a pond or something in the middle of your watershed, later on we may add the entire reservoir because it can model reservoirs, but we don't. All we care about right now is what flows into Spring Lake. So we're going to leave that alone. So we're done. Let's exit. Now it's going to write all those to your geodatabase. And you can see that all of our subbasins have been defined. We also have the longest path within each subbasin, so the longest path that a water molecule has to take. So for example, if you look in this subbasin, a water molecule that lands up here would have to travel this whole length to get out of the subbasin. Well, this is on a flat area. That may not be the most accurate subbasin, but you get the idea. So we're going to go ahead and go SWAT project and make sure we save. And that's the next step, step 2, which is delineate the watershed. Once you have your watershed delineated, you can also come up to the Watershed Delineator button and choose Watershed Reports, and then you have the option to look at a topographic report. This brings up a simple text file that gives you some basic topographic information for your watershed. So since we recall that we defined our z-axis in meters, it shows the minimum elevation in our watershed is 197, the maximum is 236, that's meters above sea level. The mean elevation, the standard deviation, and then you see the breakdown of the percent of area below a particular elevation and the percent of the watershed that it represents. And so this is just some basic elevation data that can be plotted and might be useful, might be useful to you. Then you'll see that the same values are broken down for each subbasin. So you can see subbasin 1 is relatively flat and relatively high. That's probably higher up in the watershed. And so that's just some more information you can get from the model.